Hello YouTube. So today I'll talk about Newton's laws of motion. There are 3 laws of motion that are given by Newton and the scientists of the 17th century, which describe the motion of all the objects in nature. The first law is law of inertia. Inertia is basically laziness. Law of inertia says that if object is in motion, it keeps being in motion with the same velocity, so with constant velocity. And if the object is actually motionless, it keeps being in this status of being motionless. So for example, if the marker is here and nothing moves it, like my hand is not interfering with this marker, it keeps being in the same place, right? You can't just, this marker out of the blue is not going to be moving anywhere. This means that if it's in motionless state, it keeps being in motionless state, and that is law of inertia. And if something is going with constant velocity, it keeps being in that state of constant velocity. So if you go to outer space where there is no gravity from any planet, and if you throw something or just drop something, basically not drop something, but if you just give something some force, so you throw it, if you throw this marker towards this direction, the marker goes with the velocity that you give to it initially forever, unless it is stopped by something. It hits some planet, or it gets gravitated towards some planet or something like that. But if nothing interferes with the motion of constant velocity motion or motionlessness, then it keeps being either in constant velocity or in motionlessness state. Okay, this is law of inertia. This is basically why this is why safety belts in the car are for. So you are moving with the car, your body is moving with the car, right? If you're not moving with the car, then you're gonna be left behind the car. That's just so funny to even think about. So when you're in the car, and when you are going with the car, then your body wants to stay in the motionless state. Now, if all of a sudden you hit your brake pedal, then what happens is that the car suddenly stops, but your body wants to be in motion just like before, just like an instant before, just like its previous instant. So therefore, your body basically gets towards the windshield, and then basically the safety belt is what prevents you from getting hurt. Also, suppose that you're at a red traffic light, so you're sitting in the car and your body is motionless. So now, what happens if you suddenly start moving and you suddenly press your gas pedal? What happens is that you somehow feel like you're pushed into your seat, and that's exactly the reason. Inertia is the exact reason for it. Why? Because now the car start moving forward, but your body is left behind. So your body is still in its previous situation of being motionless. So that that's why you feel like you're pushed back into your seat, right? So this is because of inertia. Basically, the fact that objects that are either motionless like to be in the motionlessness state, or if they go with constant velocity, they want to keep being in motion with constant velocity, unless something stops them. Now, let's see what happens when something stops them. And that is Newton's second law. basically Newton was so genius in that respect, where he basically was able to categorize motion in two different categories of constant velocity and motionlessness, and velocity that changes. So changing velocity. This is a separate category compared to velocity that is constant, So if you change your velocity, we previously we're talking about this. Change in velocity means acceleration. Newton was so genius and so smart that he figured out this acceleration is directed always to some sort of a force. Always to force. How? This way. So acceleration is always directly related to some sort of a force, and please write this as net force because this is a summary of all the forces that are acting on the object. How? So acceleration times the mass of the object gives you the net force that's on the object. Okay, so let's step backwards. What we said was that we basically said the law of inertia tells you that if your object is standing still, it keeps being in that position. If this marker is on this board, it keeps being on this board unless I exert some force on it and I pick it up. If no one touches this, this is going to be in this position forever. Now, if this marker is going with constant velocity, it wants to keep going with constant velocity unless something stops this guy from its path. Then, if something interferes with the motion, we go to the second category of changing velocity. Why? Because if something, let's say this is going and I stop it, so the velocity changed, right? It was, let's say, 1 meter per second. Now it's dead zero. Right? So we get to second category of changing velocities. Whenever velocity changes, we learned that it means we have acceleration. If we have acceleration, there is always some sort of a force that's related to the acceleration. Always acceleration, always related to force. Always related to some force. How? This way. Net force on the object equals the mass of the object times the acceleration. So as long as you change your velocity, you know some sort of a force is coming into play. And I told you before, because I told you if you are driving by, like, let's say 40 miles per hour and you change your velocity to 50 miles per hour, you see the speedometer changes its number, you know you already pressed on your gas pedal. So there is always some sort of a force when you change your velocity, or namely having acceleration. Okay? So what is mass here? Mass is basically the stuff that that an object or any object is made out of. Okay? So let's rewrite Newton's second law once again. F net equals mass times acceleration. This is mass. In SI system, it's given in kilograms. In SI system, acceleration is meters per second squared. Hence, F net is the units form F net is kilograms times meters per second squared. This is way too long for a unit. Hence, we abbreviate this in honors of Newton as 1 Newton. So the unit for force, unit of force is newtons, or kilogram meters per second squared. That is the unit for force. We abbreviate it by N. Okay? What is mass? I said mass is basically the stuff an object is made out of. For example, a block of gold, let's say, has 1 kilogram of mass. Double the size of that block of gold is 2 kilograms of gold, right? So this is basically what we mean by mass of something. I'll talk about the rest of Newton's laws and everything in the next video because this is getting too long. Bye now.